So the card should flip, and there we get it. There's our HashLip. Hey, welcome guys, Daniel here, aka HashLips, and welcome back to an exciting episode with this whole series of creating an NFT blockchain game. Now, what we'll be creating today is this. You'll be able to connect to the blockchain, specifically the Polygon blockchain that we're going to be working with. You can then create NFTs, and these are actual NFTs on the blockchain which you can play with. And when I say that is you can look after these NFTs. So let's go ahead and create one. You can see that we'll be interacting with MetaMask, and throughout this series we'll do things like working with Truffle, working with Ganache CLI, working with Remix, doing all these fantastical things. And if you don't know any of the concepts of ERC 721, Truffle, Remix, and all these things in development, don't worry, because I'm going to make this in a kind of beginner-friendly way, but you do need to know a little bit of coding as we go along. As you can see, we have created a HashLip, and this game is actually live on the Polygon blockchain. So if you actually go while this is being loaded, if you go to the blockchain, you can actually, let me just refresh this. This is called the HashLips beta game, beta v1, right? So beta. But anyway, you can see that 32 seconds ago, we created token ID 99. And indeed, we can double check this by flipping this card to reveal the beautiful NFT behind it. So I will show you how to do this and how to set up this basic game-like structure, which you can then take and go further with and make something amazing. So basically for this game, we can do this. We can flip the card now. The blockchain is a bit slow. I guess there's a lot of people on it, but there we go. It was confirmed. So the card should flip, and there we get it. There's our HashLip. These are HashLips NFTs, and there you can see it's ID 99. It has endurance, levels. It looks like a fire type. It looks cool. This image is generated with DNA. We can click on it. We can kiss and bite and do all sorts of cool things. We can feed it items. We can upgrade its name. We can transfer the NFT. So all very cool, and I'm going to show you how to do this step by step. So stick around with me, and I hope you guys enjoy this tutorial. Lastly, like and subscribe to this channel. I really appreciate all you guys' good feedback. The thing that I just want to start off with explaining is ERC 721. Now, this is a mouthful, and to some people this might seem challenging and daunting at the same time. Now, all we need to understand about ERC 721 is that it's a standard. It's an interface in coding terms. And what is an interface, right? ERC 721 interface or standard basically tells us that any NFT, to be considered an NFT and non-fungible token, needs to have the following functions, and that is transfer, approval for all, and we can go on, balance, owner of, transfer, safe transfer. It has a few of these functions. Now, you might look at these functions and think, well, I'm not looking at this tutorial because you're just naming them. I understand, right? We need to go into depth on this, obviously. But in all honesty, you don't really need to know all of them in depth because there are libraries out there such as OpenZeppelin, which actually has fine implementations of these functions already, which we can piggyback off. But needless to say, I will go into some of these functions as we use them. All I want you to know for now is that ERC 721 is a standard of doing a non-fungible token. And the reason why this is important, especially on the Ethereum blockchain and on Polygon, is because marketplaces such as OpenSea, if you just look at OpenSea's documentation, they actually rely on you using the standard. And if you do use the standard, you'll actually be able to see your images, you'll be able to see the item counts, the owners, and also transfer and do a bunch of NFT-like things. And that's what we want to do, right? So just understand that that's important. You also get BEP 721, which is for Binance NFTs, but we won't get into that for now. It's just for you to understand that it's a standard, right? And much like I've mentioned just now of the libraries out available, we get OpenZeppelin. Now, OpenZeppelin is kind of a community or a group of people. I don't know how many people they are, but anyway, these let's call them people, whatever. Like, these people are so awesome. They've put together contracts that has been tested and audited and are really good and convenient to use, right? So you can see that this is a simple ERC 721 contract, and this is a smart contract. Now, we'll get into what a smart contract is briefly, but you can see that here is the structure of how it looks. And as we scroll down, you'll start to see things that we've just seen in the previous thing, in the previous standard documentation, right? So here's a balance of and an owner of. And when we jump back to OpenZeppelin, we can see there's a balance of and owner of. And these actually have implementations, whereas the previous one just says that we basically need a function like this and like that. But these are actually implementations implemented in the code. So you can basically use this contract and make an NFT with it, okay? Because it has all the necessary functions that we need. Okay, so basically that's what it boils down to. And so we can use this definitely for our NFT. So let's just get started by looking at some other concept quickly, and then we'll get coding. How the blockchain works with the smart contract and how we are going to interact with that smart contract on the blockchain. So if you can imagine, here at the bottom there is a rectangle, that's the blockchain. And also let's imagine this is the Polygon blockchain, the Polygon network where the blockchain is running on, okay? Just for argument's sake. What we then will have is this smart contract over here. Now, the smart contract is sitting not on the blockchain, if you can see it at the moment. Currently, it's sitting outside of the blockchain. So a smart contract you can imagine as in JavaScript as a class or an object that's instantiated and has its own state. It's like a little state machine of itself. It can have variables, functions, and it can manipulate the data, right? But a smart contract that's not on the blockchain is useless to us because it can record state, yes, but it doesn't do it forever and publicly and live on the blockchain. And that's what the blockchain is all about. It's about things living on there forever. That's how miners get to mine the blocks and make sure that they validate everything. It's a bunch of things to explain, but anyway, let's just get to it, right? So what ends up happening then is once we've written our smart contract, we go and deploy it on our blockchain. So there it goes, pop, 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 and now it's on the blockchain. Now we have an instance of this smart contract on the blockchain. Once this process has happened, we cannot change the smart contract. We can change the one that's outside and redeploy it, and we can have another instance, but we cannot change this one. As soon as this happens, this gets an address, much like your wallet address. This address points to the smart contract and allows us to create an instance outside of the blockchain, referencing the one in the blockchain with that particular address, and call functions and read values from it. Now, how would our game read values from this smart contract on the blockchain? It would need a provider, and our provider is MetaMask. So you've noticed on dApps it says, okay, cool, if you don't have MetaMask install it. The reason for that is because MetaMask makes the browser a dApp browser, right? A blockchain compatible browser where it can kind of read and approve the users with their private keys to the blockchain and make sure that it's the correct user who wants to interact with this blockchain. So basically our game, which is our browser, will interact, and MetaMask will interact with these contracts on our behalf. Well, Yes, well, Web3. But anyway, it all comes down to this, right? We get MetaMask. We are allowed to interact because we know we can approve this user that it is. That's why you usually have to sign things the whole time on MetaMask, because MetaMask wants to make sure that you are the person who you say you are. And that's why private keys and public keys are so important. But anyway, that's the structure, right? So our next step is going to be to create the smart contract. Now, we are going to do that in a tool called Remix, and we'll get to that right now. But that's just something I wanted to get you guys to understand. It's time for us to write some code. Now, the best way of doing this when you start off is going to remix.ethereum.org. Now, what this is a browser IDE and Solidity compiler combined so that you can deploy your contracts in a JavaScript virtual environment or on the blockchain and actually test them out in development and production. So I'll show you how to do this. The reason why I want to start off by showing Remix instead of Truffle and Ganache is because I want to first create our smart contracts here, then move them over to more stable setups. And the reason for that is because I really want to drive home the fact that smart contract that we're going to be writing and the front end are completely separate. So let's get started. This is Remix. On the left, you have some options like your compiler, your deployments, and also plugins. You can activate these two down here if you don't see your compiler and your deployment setup. And then you have your files. You don't have to worry about this too much. What we can do is actually create a new one, a new workspace. Okay, so now that we have our workspace set up, you'll notice these folders down here. Now, for our purposes, we don't have to worry about them. The only folder that we are going to be working in is this contracts folder. Now, these contracts folder is by default given to you when you start a workspace, and it has these examples. So you can see there's a storage.sol, a ballot, an owner. Now, basically, these are just example contracts that you can test out with and build on and just deploy it to see how Remix works. But we want to create our own little smart contract from scratch. And what Solidity compiler does is it compiles the Solidity code that we are going to be writing here into bytecode that it can deploy on a blockchain. All right. So let's get started by right-clicking on contracts, saying new file. And for our purposes, we're going to say counter.sol. Now, the reason why we say counter.sol is because we want to make a counter contract that's just going to increment an integer. Now, the next thing that we want to have a look at is when we go back to the ballot or any of these contracts, we notice that at the top there's a license. I usually just copy this license and paste it in our contract, and then I change this to maybe MIT. I don't really know the use case or know what to put there in general. I guess this is just licensing to show the license of the contract and who can make use of it. Next, which is really important, is the pragma line. So if you write pragma and Solidity, this will actually tell the compiler which Solidity version to use when compiling the code. So for example, if we say 0.6.0 and we end that off, then when we go to the compiler section, we can see that the compiler automatically selected this compiler. This especially happens if you put on auto compile, and I always put on enable optimization. But we are not going to be using 0.6.0, we are going to be using 0.8. And the reason for that is it's the latest kind of versions, and that's what I want to use in these tutorials. Next, you can see that the compiler updates, and one last thing that you can do is you can put a caret sign above it, so in front of it, so that it says or communicates basically to the compiler saying that any compiler would work above 0.8.0. Usually you will just specify your version or specify two versions, which you can say versions between. Now, next what we want to do is actually start writing our contract. How do we do this? It's very simple. To write a contract, you just start with the keyword contract with a space and give it the name of the contract. Now, a good convention is to follow is to actually use the same name as your a file name, so I'm going to just do that. You can just say counter for the contract name, put curly brackets, and then we're going to open them. Now here's our contract, and technically we can deploy this. If we actually go to the deployment section, we can deploy this, but this will be useless because there's nothing really in our contract. The next thing that we want to do is define some variable that we want the contract to save. So we're going to declare uint 265, which is just an integer, and then we're going to call it count. We're going to end it and put a enter so that we have a little bit of a line, because now we have to declare a function. So how to declare a function is just you write the function keyword, space, give the function a name, and this one we can maybe call update counter, and then brackets. This is where our parameters will go in, curly brackets, and then open them. Basically, you can see the structure of this function is much the same as any other programming language. This is a strongly typed language, so for the parameters that you enter there, you are going to give it some types. So for instance, we're going to update the counter variable, so we want to actually input a parameter similar to uint256. So we're just going to say uint256. We're going to put a parameter name, which we'll call new count. Okay. Then once we have that, we can actually use the new count variable in our scope. So we can say, well, turn the count into the new count. And that's it. And there's a smart contract. The last thing that we need to just worry about is visibility. So we just want to make this public, this function. And by making this public, you'll actually be able to see it and work with the function outside of the contract, outside of the blockchain as well. And you'll have visibility over it. To get visibility on the count as well, we're also going to make this just public, because I think by default it's private. Now we're ready to deploy our very first smart contract. What you want to do is you want to actually head over to the deployment and run section. Make sure that you've got JavaScript VM selected. These two are more for if you want to use MetaMask or a injected provider. But we're not going to do this now. We'll maybe use this later when we deploy to the actual blockchain. But for now, a virtual machine on the browser to run your blockchain is perfectly fine. Lastly, just make sure there is an account selected over there and leave these things as they are. And then select your counter contract. So there we have it selected, and then you can hit deploy. Once you've done that, you'll see that here at the bottom of the logs, you can see a little check mark, and you can actually open the transaction and see what's happened in there. Now there's a bunch of things that we can have a look at, but this is not what this tutorial is about. It's basically just to show you how to deploy a smart contract and test it. So what we're going to do over there is, you can see deployed contract, we have one, you can expand it, and there you get to see our little smart contract. So we have the count variable, which if we click it, you can see it's a blue button because it's a call function. It means that it doesn't change the state of the contract itself, but it just returns to us the value. And because we haven't predefined count and said, well, this should start off with 8 or something, it's just going to return 0, which is the default of the integer. Next, what we can do is we can actually use our update counter, and we can see that it takes one parameter, new count. You can add as many parameters as you want, and they'll all fill in here. And this is where you can kind of enter a parameter. So let's make it a 65, and we can say transact. When you do that, the logs will again do a transaction on your behalf. And when we check the count, it's now 65, meaning that we've updated the state. So in essence, smart contracts like these are little bits of code that just is like a state machine, which keeps state, which can manipulate state, and that's all you need to know about a smart contract. The other thing that I'm just going to briefly touch is inheritance, because like I said, we're going to be using it in our smart contracts going forward. So what you can do is, let's copy and paste this whole contract over here. Let's duplicate it. Okay, and we can't have the same name, so let's call this something else. So let's call this my counter, and my counter is not going to take anything. But just to show you how inheritance work is we are going to give it maybe a string. So we're going to say, well, let's give this a string name. And actually, let's define this name. So let's say this is a new counter, like so. Just so you can see strings as well. But anyway, here we have got my counter and a name for a variable, and then we have got the counter. Now you can have these both in the same file and it can still deploy, because what you do is you go to the deployment section, and when you select your contract, you can see there's the two contracts. Usually you will split them up, which we'll do just now, but you can select my counter, deploy it, and then you can actually see down here that we have no variables because we need to remember to make this public. So let's quickly do that. So make this public, redeploy it again, and open the new one. And there you can see that we have the counter, and we need to make sure we've selected my counter, deploy it. There we go. And there's the name. All right. And if you query the name, you can see it's a new counter. But now, what is inheritance? So let's close all these smart contracts we've deployed. How do we actually get all the functionality of counter in my counter? Well, you do that by inheriting. And how you do that is you can say is. So you're basically saying my counter is counter. And you can append as many contracts as you want, inherit from as many as you want. But basically, by doing this, if we go to the deployment section again and we select my counter now and we deploy it, we actually can see something interesting happening. We see our name variable, which we can still query, and it says new counter, but also we see the count and we have the functionality to change the count. Although this functionality does not sit inside my counter, it's inheriting from counter, meaning that the underlying structure is a counter. And that's basically the concept which I want to convey, because this is how we will be creating an NFT and actually make use of the ERC 721 contract, which we will inherit from. Lastly, like I mentioned, you don't have to keep these contracts in the same file, which is good practice to split them up. So if you look at this, if we just say create a new file, and this one we call my counter.sol, basically like that, and we copy all the stuff from my counter.sol and place it in there. We also need to remember to actually get our pragma and the license definitions. Once we've done this, we basically have split up the contract. Now, counter won't moan because it's not dependent on anything else. But if you look at my counter, we're saying that this is type of counter, but it doesn't know where to find it. And a simple way of doing or importing the counter is just by saying import space and then define the path to counter, which is in the same directory here, and we can just say counter.sol. So once you've done that, this will work exactly the same, and this is what we'll be doing next. So in the next video, we're actually going to be starting with the programming of the smart contract, NFT smart contract and game. So stick around, I'm very excited, and thank you for sticking this long. Please remember to like this video, subscribe, and I can't wait to now actually get started on the game.